Hello, everyone. Welcome to this workshop session of the conference. Thank you for joining. My name is Ghislain. Julien is over there distributing ref cards for the tool we use today. The way the presentation is going to be laid out is I will start with a general presentations about where we're coming from with this tool. Then there's going to be a live coding session in the middle where Julien will perform in front of you a tutorial on Guix that you'll be more than welcome to follow. And then there's going to be closing slides on where to go next. Can all you guys hear me okay? Or shall I speak louder? Fine? Okay. There were some instructions that were sent, I think it was last week or 2 weeks ago, to set up your machines. Can I have a quick show of hands on how many people have successfully have a running Guix instance on their machine? Okay, so we got access to HPC resources a bit late, but we have some. During the first presentation, Julien will ask you for your name, first name, and institutional email. And with that, he'll be able to set up an account on HPC resources where Guix is already installed. Okay, and this way, hopefully, you'll be set up. All right. So before we start, so the presentation is available on the first URL. So feel free to connect to it and follow the slides. Same online for the people following us. The source code for the repository is also available in the second URL. That's also where the source for the example we're going to use for the tutorial. That's where the sources are. Another option is if you want to send us your emails and first name and last name through Slack, through direct DMs, that actually would be more convenient. And we regularly will leave time for questions. So if you have burning questions, don't worry. We will have regular intervals where we'll ask for questions. You had a question? All right, so let's start with the motivation for this workshop. And first, we need to give what our own meaning of reproducibility is, because it's a heated debate in many of the scientific communities. So we will take these two definitions, which are reproducibility is the ability for independent investigators to draw the same conclusions from an experiment following the documentation shared by the original investigators. What I like with this definition, it's completely independent of the field of research, and it's completely independent whether you're doing computational research or research that requires access to computational resources, or if you're doing research in clean room environment, for instance, okay? And we draw the distinction between replicability and reproducibility by insisting on the fact that reproducibility requires changes, okay? Whereas replicability, where the aim is to basically freeze the experiment forever, like avoids it, okay? So the goals of reproducibility is to deal with the sources of variations in a given experiment, okay? And these sources of variations, they can either be induced, like you have no control over it, or you can provide means of control to manage these sources of variations, okay? So based on that, we can draw two goals, one on the individual level, which is basically to ensure that you have as much control as you can on the sources of variations in an experiment. You will never reach it, but the aim is to maximize it as much as possible. And from a collective standpoint, is to decouple experimental results from the original observer. obligatory quote from the famous Nature paper. I like to insist on that one, which is more than 70% of researchers have tried and failed to reproduce another scientist experiment. Okay, so here the source of change is a different observer, and more than half have failed to reproduce their own experiment. So here the source of change is the time point at which the experiment has been rerun. Okay, so common source of variation, different observer, future time, additional data. You submit your paper for review, reviews come back, they say you need to do further experiments with new data. This is another source of change, etc., etc. So why does reproducibility matter? First, there was a study that showed that scientific findings are often inaccurate. That's correlated with many things, but mostly by the way modern science is performed. Non-reproducible science actually costs money. And if you read, like there are a flow of papers these days that explains that academic retractions are on the rise, and of which experimental errors account for an estimated 25%. That doesn't mean that there are reproducible errors, but the reproducible errors are contained within this 25%. Okay. That's what we're dealing with. Why is science difficult to reproduce? So first of all, we need to take a big picture on this. Failure to reproduce can come from the empirical aspect of it, so from the collection part. Can you recollect the data? So that's addressed by open data, explanation of the experimental protocol and documentation. There's statistical reproducibility, so that's addressed by study pre-registrations. And then what's united us today in this room, there's computational reproducibility. So that's the measurement part of science. That's addressed by documentation and fair practices and tooling. And with modern research relying more and more on software, the importance of computational reproducibility keeps rising. So the challenges for specifically computational reproducibility. First of all, there's the availability of code, data, and programs over time. There are some studies that shows that there's link rot is building up, and the older the study is, the less likely you get access to the original material that were used to produce the results. There's whether you have sufficiently detailed instructions to reproduce the experiment. That's the pure documentation part, okay? Not just the paper, everything that was submitted alongside it. And then there's the actual capture and deployment of the necessary computational environment, which is addressed by the tooling part, okay? And the case for Guix, so, and why we are proposing this workshop today, is that you can achieve transparent, verifiable, and long-term reproducibility with a single comment, which is highlighted here, okay? And the rest of this workshop will be about explaining the different parts of this comment. Okay? Are there any questions so far? All right. In that case, what I would offer is that you we'll move on to the practice section. So the practice section, what I will do is that I will explain to you what the experiment consists in. Okay. So basically what we are going to manipulate, and then we'll switch to the live coding session. Okay. Did you get all access to the repository? Which is here, the second URL. So move to this repository.
I was just going to ask a question.
Sure.
So you kind of motivated it all being for the reproducible problem in science.
Mhm.
Do you have any ambitions for this being more widely adopted in other contexts, or...
So that's going to be in the closing slides, but a little bit of a teaser. In order to address that problem, there are first and foremost societal and political parts that needs to be addressed. So it's not just a technology / tooling aspects that needs to be sorted, in my opinion, but I think it's widely verified just by the fact that I think if you ask your lab or ask a PI, is reproducibility desirable? The answer is going to be yes. If there's a deadline, should I skip reproducibility? The answer is going to be yes. But we'll talk about it towards the end.
Thank you.
So in the README of this repository, you'll have all the instructions to access the data, and the source code is under the SRC folder. And I'll walk you through what's inside this, okay? So our case study is basically a subset of a larger neuroimaging pipeline. And here we are assuming that basically the experiment is well defined, has sufficient documentation to produce it, and the project dependencies also are known over time. So basically you can't use Guix or any other tools if you don't know upfront where the data are and what are the dependencies you need. Okay, that's the basics when you share code. So we'll attempt to Guixify this experiment. And the computational workflow is as follows. So the data you will download, there will be a structural data set. So it's a data set that contains brain MRIs. And there's going to be an anatomical template. An anatomical template is basically a big average over a population of the same brain images. Okay. The first step, so the picture on the left is the data as it is. The first step will be what we call a bias field correction, which will basically correct for the field inhomogeneities coming just from the MRI measurement itself. The second step will be a registration to this anatomical template so that we ensure that all data are aligned properly. Here, for instance, you see that between the first slice and this is technically the very same slice. It's just that because the head has been tilted a bit, you have more brain structures that are coming back on the same slide. Okay. And finally, we do a skull stripping. So we get rid of the skull, which is not useful if we do further analysis of the brain regions, for instance. Okay. So that's really, if you take the code, you take the data, you run it, this is what you would get at the end. Okay. I've provided a Conda. Typically, you would provide a Conda environment with your direct dependencies, not the indirect ones. We would come back to it, but just the direct dependencies. You will activate your environment, and then if you run the code, you will get these 5 files that corresponds to the images that I've showed you. Okay. And amongst the dependencies, we'll walk through it, but we have a fossil that's known to be a tool, like a basic tool of the neuroimaging stack. And we'll have a few Python tools that are going to be the things that we're going to try to Guixify. Okay. And once you follow the setup instructions, the way you run it, first run the first command on one subject to verify that the full processing can happen with your Conda environment. Okay. Then, if you want to process all the participants, I add the -j number based on your machines to get it faster. Okay. I don't think we'll have time for the third example, but I provided an additional tool that we could basically a branching of the processing pipeline. So you can choose an alternative tool to do one of the steps. I don't think we'll have time to process the OMS to do the bias field correction. And based on that, we'll move to the live coding session.
We can start with the dependency in the environment for the PML. We see that we need a click, so we need to find click in Guix, and we can say okay, Guix okay, we see that we have a lot of Python click with the version. So okay, so the idea is to create
And if you guys
manifest file. Manifest that's the end.
that's the most.
And
it's on the community
and, we create the manifest with a packages, open a new bracket, list, and we list the first one is Python click. Okay.
but don't worry about it.
Okay.
I will.
So we create the manifest.html with Python click. So the command is Guix
The problem.
dot m manifest, and we see that there is an error because we need a module, and we can see that Python click is defined is a Python x equals z. So
one reinstall. I'm struggling with my install because I don't.
no. Then
It's gonna be good.
we go back to the each cell. Okay.
I can start. I haven't seen it. Yeah, it's not. It's a little issue. It's like when you're on the login, it's more fun if you're trying to do a computer. You basically have to go to use.
So you just put
some service to do that instead of both, so that like lots of service.
Microman. Well, I mean,
This as well.
I have not been able to get the.
Yeah.
No. Yeah,
The way I could.
Toujours le use module qui marche pas. Non, c'est manifest package. Package. Ouais, d'accord. I'm sorry.
Who else doesn't have a working conda environment that can reproduce the experiment? You.
So you can see what we are in a Guix environment is a Python click, and if we try to open a Python interpreter and import click, it does not work, and that's because we are not in a containerized environment. So I have just the Python click module, but I use the Python environment of my local machine. So shows this if I go out of the environment, I can use .c to say, okay, Guix shell inside the container. And if I do that, I am in a containerized environment, and I can see that I have no Python. I have no interpreter. I just have a. So I say, okay, I have to add Python to my manifest. So same thing, Guix search Python. I can choose which version I want. So I want the last one. And I can see is it in a GNU packages Python. So I reopen my manifest. I add Python. And I add the module. Okay, so now if I try to create my environment, I am inside. If I want to see where is my Python, it's not possible because I don't have which. I have to add which to my manifest if I want to see that, but I can go inside with my interpreter and import Guix, and we see that it works. So now, second step after click, we want to hide NIPipe. So we can do the same, Guix search NIPipe. You see that is it available, but for the workshop purpose, we try to create our own receipt of NIPipe. So for this, we can do Guix import PyPy to say each channel we want to import NIPipe. NIPipe. And Guix is available to define directly and to give us definition of Python NIPipe. So I take it. Passed in my manifest. Git to the list dependency. And I can so if I do, I say okay, it's not possible because I need some module, but Guix give me directly which module is missing. So I just have to apply and paste in my import list. So the same error, but with a new module to import. So same thing. Same thing. And okay, I made a typo error. So now say okay, but in NIPipe we need a Python request and we don't have. So same thing, Guix import PyPy, ask for a new. It's able to give directly the definition. And now he asks for a new one, Python telemetry. So now we have a new error. So because maybe just say we don't have a source available with PyPy for its telemetry. So we can go in variant and we find the definition. Just a wheel, but no source available. So in this case, we need to go to the GitHub and we have to write the receipt. So how to do that? Go in the manifest and we have to write some code. So define public, the name of the module. So okay. Package. So we do exactly the same that the one below. Version. You can see the version we want. It's 2.3. Now we need a new method to get the source. So we use the PyPy URI in the other case. Here we want the GitHub query. So the method is git fetch. Fetch is the URL. Here we can see that the version is v 0.3.1. So we need to concatenate two strings. So string append v and version. The chart, so you can use the Guix download command. Guix download with the URL of the repository and the version we want, and we have the chart. Okay, and now we need to define the build system. the propagated input. You can see, yeah, the propagated packaging request and CI info. So test, test code, and versioneer.
Sorry. Could you comment on why we need to include development dependencies and things like that?
What?
Why do we have to include development dependencies and things like this in order to get a reproducible build?
So you don't have to. Here it's because by default, so if you look at the package definition, build system, the line of build system, if we look at the anatomy of the X module, it's basically first the name and version of the package, then where to fetch the source from, PyPy or Guix, as Julien is doing regularly. Then there's what receipt I'm going to run on it. That's the big system now. Okay, it says it's a system running a Pi project on, so I'm gonna run these specific components. And then there's the dependencies that you're gonna run to run the full receipt. And in this receipt, there's automatically the tests are run by definition. So what happens is when you do a Guix import, it will fetch the PyPy metadata, the buffer package metadata, and try to auto-fill the propagated inputs, which are the runtime dependencies, and the native input, the dependencies. But the issue is that in Python, there's not exactly an established way of saying what's a test dependency, what's a dev dependency, etc. There are some people who pay dev and put some things, but not everyone. Some people put test something, and not everyone. Some people put style also in the PDF. They get their MyPy stuff in it as well. So what basically Guix does is says everything that is not a runtime dependency, I put it in native inputs, which is helpful. But that being said, it's useless to run the test. The Guix cannot know upfront. So you need to do this extra checking of the auto-generated manifest and clear the native inputs that are just for styling or just for running CI or just for checking the type inference of the code. Okay. To cut it through to just what's required to run the tests. Okay. Most of the time, if you have a package that follows a normal convention, it will hit it properly. But NiPy, the main Python dependencies that we started with, is an offender in some ways. But here the aim was to show you that the world of creating packages is not always filled with very nice packages that behave. And we show you some cases where you need to step aside of the normal way of the normal package definition. For instance, we have a PyPy package that doesn't publish sources. It happens. Some packages publish only means. So we need to fetch the source somewhere else. Here with GitHub. you have packages where you can't run the test because they require external data. It's unfortunate, you can't. In that case, we'll show you how to disable the test. There's no point trying to do something else to disable the test. We'll show you all of this, all the real use cases that you might find. If you also publish Conda packages or Debian packages, I don't know if there are Debian packages or Conda packages in the room. We're also faced with this difficulty. It's a regular thing about.
So as you can see, I had some issue with a bracket. It's a scheme issue. So we need to be aware about open and close the bracket at the good place. So here we need to declare a source, then origin, then the method to get the code. Then for Git, you need a URI with a Git reference URL, then commit, and the chart. So we need to close the bracket for source here. Then after we can define the build system, then all the propagated input, then the native input, page, synopsis, description, and the license. So normally we have to define the license. For now, I just put a false to say, okay, I don't define license for now. I have to do.
Figure it out later. So if you don't know the license ahead of time, you can just put that. And
So
do the comment saying fix me, or I'll find it later. It's fine. If you do Guix import from PyPy, you go to the license metadata and it will fill it up for you automatically. Here for the Git part, we need to actually do the repository.
So the first error is with my bracket. I fix it, and now I can see that it's okay, but I use the Git fetch method, so I need the module to download. So just need to add it. And so on. So I can Nivavel. So I need a new module. Another one.
Is there a way to get all of, I mean, this just seems a little bit bonkers to me that you have to go one by one and it will one by one bring up the things that, you know, you have to put in your file here. I mean, it's just, from experience, like, good luck getting users to go through this every time. It just seems incredibly.
So there's an easy answer to this. Try to package something on Conda. And what's going to happen is if you don't know the dependencies ahead of time, you have an import error and you go through the same problem again and again.
So
I'm not saying it's in defense of it. I'm saying that anyone who has experience in packaging in any system, because I used to be a Debian packager in my past, and I went through the exact same issues every time.
And if you it's for the workshop purpose. You can, if you want, you can see all the dependency and make a Git search to see if it is and if it is available on which module, and you can add all your module on one time. But for the workshop, we decide to do.
And I was to say that here the nice thing is Guix tells you this is the command you need to do to fix it. Whereas when you have an import error and you need to find out what the actual Debian packages are that ships this, which is not always the name you suspect it is.
Yeah.
At least it's a bit iterative, I agree. But at least you can just copy paste the thing and move on. Whereas if you've done Conda or Debian packaging, it's really not the same deal at all.
And we could by Guix import dash R, like a recursive one, and we have this if you want, and the other one you need. But with Python, you can have a lot of receipts, and maybe it's too complicated, so do one by one. So now we need a new module. So it's import right. And we have our definition. So
here, coming back to an earlier question, here we have the same problem. You see that we have the FLAC8 packages that are brought, MyPy, etc. It's because again, Guix parsed all the package metadata. It found what the propagated inputs were. It says this is all the other dependencies. I'm not quite sure what they're from, if it's for documentation, dev, etc. I have no idea. I list them. I list all of them anyway, and you figure out what you keep and what you discard. Okay. So here we've done the job already of picking the ones that were necessary.
So I give the answer, and I keep only the one I need, and I remove the license for now. And now a new one. Same solution.
Convention, you then contribute to it to a repository, then in alphabetical order.
Python coverage.
Well, your mileage really doesn't matter.
Okay, is it new packages? Check. So I have to add it. Ghislain, tu te souviens ça?
You can get rid of it. It's an optional dependency.
Okay. J'enlève NBSphinx.
And these things we don't need, it's the documentation.
Ça non plus.
And to be honest, on iPipe, I think we could skip the test. We could show how to skip the tests.
Faut que je skip les tests là-dessus. Alors, tout ce qui
So the default, or just so I understand, the default is that it runs the test for every single dependency that you have to
Yeah.
make sure that the dependency works. Is that
It's because what happens is, let's say we have an update of a dependency. We want to ensure that the full graph of all the dependent dependencies can still run with this update.
T'es OK avec cette.
One feature of Guix is that when you install something, you install all this dependency graph with it. And unlike Conda or Debian, a package can happily live with different dependencies than others. Usually, an example would be, let's say you depend on package A that depends on a specific version of a module. You have package B that depends on an incompatible specific version of that module. Guix will happily install both.
okay?
Whereas on Debian, or even if you do pip install, pip will say, I have a conflicting definition, do something, decide. And actually you can even tell pip, yeah, it doesn't really matter.
just.
Yeah.
So basically, you can't have the same name for a dependency, a different version coexisting in an environment. In Guix, that can totally happen.
Okay. And sorry, how do the tests enable that? Is that just making sure that so the thing that depends on those different versions, it's making sure that they work with the.
Yes, exactly. Making sure that the dependency graph is cohesive and all the tests run by themselves.
Okay.
Which, if you're familiar with Debian, that's how what do you call it? Basically they do updates of package, they do them by stages. So they basically said, oh no, there's going to be a huge update of ITK. So we're gonna first rebuild all the package, the ITK package, all its dependencies, and then we move the full build packages in a batch of updates. So that you're not at a stage where you have built ITK, it's updated, but then all the others will fail because of a DLL error. So in that case, they do that. I think they are transitions. I think they're called. If I remember. And they're forced to do this again because you can't have two versions of the same library that coexist. Right. Whereas in Guix, it's really not a problem.
So I try the Guix shell manifest, and it begins to build. Then it fails, and I have a
We have an error, so we can access the log of it, and we can check what's missing. So if things is missing for the tests.
So it's a test in the traits, and we need Sphinx, and we. Est-ce que je fais j'enlève les tests là-dessus? So for this case, we decide to remove the case, the test.
We can add things to native inputs.
Ok, je peux essayer. Ok. Yeah. We keep the test. In 5 minutes, I will stop and we will be back. Okay. So, thanks.
Doctor Alcom. Quick one. So we're running a little bit out of time. Well, we expected there's the ideal time it would take to build everything, and then there's the live coding effect. But basically, once the manifest is running, we would do exactly the run.py that we did with the Conda environment, and we would get the same result. We have many.
control.
So once the build happens, one thing we need to explain. So far what we're trying to do is to create a shell with these dependencies, okay? What we haven't explained is that 6 months later, if you were to rerun the same thing, you would have a different environment, okay? Because by that time, the repository might have new updates or the manifests might have evolved, and you would not get the very same environment that you've built today. In order to achieve this, you would record the state of your channels, so everything that you used to get your software from. It's this channels.scm file, okay? And we will use that command Guix time machine that I showed in the first slides at the beginning, which allows you to travel back in time at how the state of the repository was at the time you built the manifest, which is today, okay? And rerun the exact same build. So that's how we achieve the reproducibility in time. The manifest gives you the reproducibility, the receipt, what you want to put in the environment, and the channels gives you the state, so what were the dependencies at the time I built it, okay? Yes.
How long the archives will persist? Because in time it's very very.
So the repositories, I think the main Guix repository has been running for almost 10 years. So the promise is that you can reproduce Guix itself and the rest since its 1.0 version, which I think happened in 7 years ago or something. Now, to speed up the builds, there is a service called substitutes that run, which basically store current builds. And when you do a new build, basically Guix calculate the hash of the resulting derivation, which is what you would get into your store, and ask the substitute, has someone already built this? And we'll fetch this instead of building from source locally, okay? Those substitutes, they cost storage and money to host. The promise is that they would stay for 2 years, which means that if you try to reproduce something that is past 2 years, it's fine. It's just that you will rebuild everything you need. It will take time, but there are regular experiments done by INRIA to try to reproduce things from 5 years ago. It's just that they provision the necessary storage and compute to be able to do it. Okay? But the substitutes themselves, the promise right now is 2 years.
Thank you very much.
And another thing, a question or a comment that I got from one of our participants is that when you're on a HPC resource and you Guixify something, it's the first person who does the build that's going to have the cost of the time of build. Someone else doing the same, requesting the same build, the same process will happen. Guix will calculate the hash, asking the store if already someone has already built it. If it's the case, I get it straight away. I don't rebuild everything. So on HPC, it's very useful to have this. So going further, you have use cases where you want to use Guix, but you don't have Guix. Typical use case, HPC clusters. If you don't have sudo on your machine, if you don't have any administrative.
Sorry, just a question on the last part.
Sure.
Can you explain a bit more? What is the entire state? What does it actually have in it? Does it have actually package?
It has the full dependency tree.
It doesn't actually have the package data.
What do you mean?
So there's a lot of URLs where you're putting packages from different places. So you should have to rely on those all being alive when you run.
I'll come into it. It's a very good comment. I'm going to explain it right now. It's a very good comment. Hold that thought. So if you in environments where you don't have Guix, what you can do is you can use the command Guix pack, and that will create an artifact that then you can provide to a user that doesn't have Guix, which is self-contained. And what it can produce are relocatable tarballs. So really just a zip with everything with relative paths into it. You give it, it runs. Docker Singularity Obtainer containers. Okay. Deb and RPM packages. Okay. And you give them to your users, and they don't need to have Guix to run the experiment that's inside, but they will get exactly the libraries and everything that you've computed with your Guix build file. So you can basically use Guix as either a container factory, and also in HPC, people replace modules, regular Linux modules, by hiding Guix inside. Because technically modules are just like overrides of paths. And that's exactly what Guix does as well. And I've put links of documentations that shows you how to do this. There are multiple channels that are available. There's the main Guix repository. There's Guix Science, where we've contributed some of the receipts that we've used today. There's always a distinction between what's open source and what's under proprietary license. So you will always have a channel with just the open source software and channels with additional non-free proprietary software. Okay, so you have Guix Science non-free, Guix HPC non-free. And a special case, we have Guix CRAN and Guix BIOC, which are automatic rebuilds or automatic imports of the CRAN R packages and the BIOC R packages. And there's many more on the awesome Guix repository that are listed. There's Guix for games, Guix for audio, etc. If you need help, there's a Guix manual and a Guix cookbook written by hosted on the official website, which have most of the informations that you would require. If you want to ask for help, there's an IRC, channel on Libera Chat for Guix HPC, and maybe at some point Guix Science, or the project mailing lists. You can report packaging issues on Codeberg, which is where the main Guix package is hosted. And if you need commercial support, there's recently they launched a company, a cooperative called Guixotic. If you want to contribute to Guix, so you've written all these receipts and you want to contribute them upstream, you can contribute them to Codeberg. That's exactly what we've both done to prepare this workshop. Contributions are very much encouraged, and there's a code of conduct that guides it. And there's a contributing section in the actual manual of Guix that gives you all the tips to get yourself started and to get the tooling, the development tooling right. Guix is also an area of active research. One is something called full source bootstrap. The idea is to say that you want to be able to reproduce the tools that were used to build the software, so compilers, etc. And most of them at some point require a binary blob to bootstrap the source of other things. So compilers need a binary blob or a previous version of a compiler to build itself. Okay. The aim is to go the farthest possible in the chain to get rid of these binary blobs that are required to reproduce everything. Okay. There's reproducible research papers. So the idea is to integrate Guix in a way that you can go from an experiment, as I showed you, and provide the channels and manifests to get reproducible papers. And then there's your question about long-time source code archival. And for that, Guix now is integrated with software heritage. And what would happen is if tomorrow one of our GitHub projects they decide to get rid of the source code, okay, What Guix does is it will request software heritage for the version of that software, because there's this hash that we've given. So software heritage, provided that it can give us the version with the same hash, can be a substitute if link hot happens for one of the package definitions that we've written, okay? And it's a very good question because we don't imagine GitHub going away. SourceForge almost got away. Gitorious got away. Code.google got away. So GitHub can go away. There are other issues with long-term reproducibility than GitHub going away. There are things called time traps. So basically code that says if I'm at a different time, I will no longer build. We have software that relies on expired sources, certificates, typically. It can be additional data. In that case, we cannot do anything about it. We will need to implement something that can provide these expired resources. We have software that no longer builds on modern hardware. Okay. And your comments before, the retention period of the substitutes, which again, it's not really an issue. It's just that as a result, you have increased build times and you will need to provision the necessary resources to reproduce something farther than 2 years at the moment. Okay. And then to conclude, I want to circle back from the beginning of this workshop. Can the reproducibility crisis ever be solved? The main issue is not a technical one. There are societal changes that need to happen beforehand. The research community has bigger fish to fry. At the moment, the advent of generative AI creates more and more fake papers. At the moment, the community is on fire to just clean the artificial mess that is created at the moment. So it's going to be difficult to motivate the research community today to focus on reproducibility when they're under attack by artificial papers. So things are getting worse with enshittification. I don't know if you know the term, but it is happening. But for everything else, like the famous ad campaign, for things that can't be reproduced, for everything else, there's Guix. I would like to thank all these people that helped us directly or indirectly get the idea and get this workshop going. And you have a list of all the references that I've used for the talk at the very end. There are blog posts, there are papers and everything. The code repository will stay up, so feel free to come back at it later. And we would like to thank you for your attendance today. Devon, we're a minute early.
Well, that could be. But can you maybe compare and contrast the reproducibility considerations versus building this sort of great parent versus just using a Docker file?
Okay. For Docker, it's very easy because there's a very high chance that the first line of your Docker receipt is already tells you that it's not reproducible. Most likely your first line is from Ubuntu latest, which means in 3 years' time, latest would be 2604. So by definition, the underlying environment will have changed. The GCC toolchain, the Linux kernel, etc. Docker and containers in general are opaque, actually, by design. Okay, they are very good for replicability. You want to freeze something forever, they're very good for this. And if your definition of reproducibility is actually replicability, it's as far as you want to go. The nice thing with Guix is that it will give you a Docker container for which you have the transparent and fully reproducible receipt for it. Your container will be a set of files with relative paths that were created from the Guix store you had at that time. So you have a really truly reproducible container that you can share. Whereas your Docker file will have at some point, even yourself, if your from image is something that is tagged, etc., there's a high chance that this very same from image has also a from Ubuntu latest that's hiding somewhere. So you would need to inspect the whole chain to find out whether your Docker image is fully reproducible. I'll also add the fact, so there's a gentleman who gave a FOSDEM talk, I think in 2023 or 2022, who did that. Like really his topic was, can I reach a state where I can have full reproducibility with Docker? Spoiler alert, it's not that easy. And it's very interesting to read actually. Did you have other means in mind than Docker?
I know, I think so. Yeah, Docker's interesting because it looks like it's really useful, but it is.
No, Conda has the same issue. Yes.
And what about SPAC?
So SPAC, I'm not fully. I don't use that tool, so I will. What I do know is that it's similar to Conda in spirit. So you will have exactly Conda, which is in Conda you have direct control of your direct dependencies. For your transitive dependencies, you don't have control of it.
No, in SPAC you can.
In the sense of how do you do it? You have a log file?
You have a log file.
Okay. Does the log file goes all the way to what?
I mean, it goes to the level of the SPAC packages. So assuming that you can build those reproducibly, then in principle you've got the same.
Okay. So all the way to the GCC toolchain that was used to do it.
So you would usually build the compiler as part of the SPAC environment.
Okay. So in that case, they are probably comparable or not.
It seems comparable, but I guess it's not built with this in mind. So
yes,
it's built with reproducibility in mind from the core.
Exactly.
SPAC, you probably got most of the way. But
I think that being said, SPAC in the mission statement is in the mission statement. I think there is reproducibility in it. I don't know. Again, I don't use the tool. I know it comes up regularly, and in the link I gave you in the last slides about the modern workflow of HPC, they show Guix and they show SPAC as well. So I think they do a comparison between them. So they might have a say about how they compare. 31. There are other questions. I'm still here if you want to have lunch. You as well.